Why do we need to learn microprocessor or microcontrollers? The microprocessor is the core of computer systems. Nowadays, many communication, digital entertainment, portable devices are controlled by them. A designer should know what type of component he needs, ways to reduce production costs and production reliable. An electronic engineer who wants to design a system must have a thorough knowledge on microprocessor or microcontroller. So, microprocessors are regarded as one of the most important devices in our everyday machines called computers. Before we start, we need to understand what exactly microprocessors and their appropriate implications. What is a microprocessor? The word comes from the combination micro and processor. Processor means a device that processes whatever. In this context, processor means a device that processes numbers, specifically binary numbers, zeros and ones. To process means to manipulate. It is a general term that describes all manipulation. Again, in this context, it means to perform certain operations on the numbers that depends on the microprocessor's design. What about micro? Micro is a new addition. In the late 1960s, processors were built using discrete elements. These devices performed the required operations but were too large and too slow. In the early 1970s, the microchip was invented. All of the components that made up the microprocessor were now placed on a single piece of silicon. The size became several thousand times smaller and the speed became several hundred times faster. The microprocessor was born. Was there ever a mini processor? No. It went directly from discrete elements to a single chip. However, comparing today's microprocessor to the one built in the early 1970s, you find an extreme increase in the amount of integration. So, what is a microprocessor? Let us see the definition of microprocessor. The microprocessor is a programmable device that takes in numbers, perform on them arithmetic or logical operations according to the program stored in the memory, and then produces another numbers as a result. Let us expand each of the underlined words. Programmable device. The microprocessor can perform different sets of operation on the data it receives depending on the sequence of instructions supplied in the given program. By changing the program, the microprocessor manipulates the data in different ways. I have told a word called instruction while I am explaining the word programmable device. What is it? Instructions. Each microprocessor is designed to execute a specific group of operations. This group of operation is called an instruction set. This instruction set defines what the microprocessor can do and cannot do. The next underlined word is numbers. The microprocessor has a narrow view on life. It only understands binary numbers. A binary digit is called a bit, which is being coined from the word binary digit. The first letter in binary and last two letters in digit. The microprocessor recognizes and processes a group of bits together. This group of bits is called a word. The number of bits in microprocessor word is a measure of its ability. The next underlined word in the definition is arithmetic and logic operation. Every microprocessor has arithmetic operations such as add and subtract as part of its instruction set. Most microprocessors will have operations such as multiply and divide. Some of the newer ones will have complex operations such as square root. In addition, microprocessors have logical operation as well as AND, OR, XOR, shift left shift right, etc. Again, the number and type of operation defines the microprocessor's instruction set and depends on the specific microprocessor. Next line in the definition is stored in memory. Before discussing about it, let us discuss what is a memory. Memory is the location where information is kept while not in current use. Memory is a collection of storage devices. Usually, each storage device holds one bit. Also, in most kind of memory, these storage devices are grouped into group of 8. These 8 storage locations can only be accessed together. So, one can only read or write in terms of bytes to and from memory. Memory is usually measured by the number of bytes it can hold. It is measured in kilos, megas and lately gigas. A kilo is in computer language is 2 to the power 10 1024. Kilobyte is 1024 bytes and mega is 1024 kilos and giga is 1024 mega. Now let us discuss about what the stored in memory means in the definition. When a program is entered into a computer, it is stored in memory. Then, as microprocessor starts to execute the instructions, it brings the instruction from memory one at a time. Memory is also used to hold the data. The microprocessor reads the data from memory when it needs and it writes the result into the memory when it is done. From the above description, we can draw the following block diagram to represent a microprocessor based system. A microprocessor is in need of some input to process, so it is in need of an input device, and before it is being processed, the input data has been stored in memory. Then after processing it, before throwing it to the output device, the processed data has been temporarily stored in the memory again back. So a microprocessor based system is in need of an input device, memory to hold the input data as well as the processed data, and an output device to display the processed output. Let us expand the picture a bit. The microprocessor can be divided into three main pieces: arithmetic logic unit, register array, and control unit. Arithmetic and logic unit performs all computing and logical operations such as addition and subtraction as well as AND, OR and XOR. Register arrays are nothing but of collection of registers within the microprocessor itself. These are used primarily for data storage during program execution. The number and size of these registers differ from one microprocessor to the other. And the control unit, as the name implies, the control unit controls what is happening in the microprocessor. It provides the necessary control and timing signals to all operations in the microprocessor, as well as it contacts the outside world. So a microprocessor is a large scale integrated circuit that does almost all the functions of the CPU. It is also defined as a CPU contained in a single chip. The basic function of microprocessor is to fetch the instructions stored in the main memory, identify the operation and the devices involved in it, and accordingly generate control signals to determine when a given action is to take place. We can say that a computer with a microprocessor as a CPU is known as microcomputer. Let us have a look on the history of microprocessor. The first microprocessor to make it into a home computer was the Intel 8080, a complete 8-bit computer on chip, introduced in the year 1974. The first microprocessor to make a real splash in the market was the Intel 8088, introduced in the year 1979 and incorporated into IBM PC. If you are familiar with the PC market and its history, you know that the PC market moved from 8088 microprocessor to 8286, then to 8386, then 8486, then to Pentium, then to Pentium 2, Pentium 3 to Pentium 4. All of these microprocessors are made by Intel and all of them are improvement on the basic design of 8088 microprocessor. The Pentium 4 can execute any piece of code that can run in the original 8088 microprocessor, but it does it about 5000 times faster than it. The tabular column shows the evaluation of microprocessor. The date in the table describes the year in which the processor is being introduced. Many processors are reintroduced at higher clock speed for many years after the original release. The transistor in the table shows the number of transistors on chip. You can see the number of transistors on a single chip has risen steadily over the years. And microns is the width in microns of the smallest wire on the chip. For comparison, a human hair is 100 micron thick. As the feature size on the chip goes down, the number of transistors rises. And the clock speed is the maximum rate that the chip can be clocked at. And the data width is the width of the arithmetic logical unit in the microprocessor. A 8-bit ALU can add, subtract, multiply, etc. to 8-bit numbers, while a 32-bit ALU can manipulate 32 numbers and so on. MIPS stands for millions of instructions per second, and it is a rough measure of the performance of a CPU. Modern CPU can do so many different things that MIPS rating lost a lot of their meaning. But you can get a general sense of the relative power of CPU from this column. So far we have discussed about the need for microprocessor, definition of microprocessor, difference between microprocessor and microcomputer, and history of microprocessor and evolution of microprocessor. That's all for today guys. Meet you all in the next video lecture. Until then, stay home, stay safe. Have a good day. Thank you.